The issue of ceiling fans and speed controllers causing nuisance tripping of arc fault circuit interrupters, or AFCIs, is a widespread problem. Many electricians and homeowners have reported similar occurrences with various makes and models of both fans and their associated speed controllers. The precise cause of this problem remains under investigation. However, several potential contributing factors have been identified. Firstly, some fan motors exhibit weak startup characteristics. This can lead to a brief surge of current during the motor's initial activation, which the AFCI interprets as an arc fault, thereby causing it to trip. Secondly, speed controllers, which are used to adjust the fan's speed, often employ electronic components that can generate harmonics. These harmonics, which are essentially distortions in the electrical waveform, can also be misconstrued by the AFCI as an arc fault, resulting in a trip. Thirdly, improper wiring or loose connections within the circuit can create actual arcing or other electrical anomalies that legitimately trigger the AFCI's protective function. Several potential fixes can be explored to mitigate this nuisance tripping. Firstly, consult the manufacturer of the fan or speed controller. They may be aware of the specific compatibility issues with AFCIs and may have developed solutions or workarounds. Secondly, experiment with different AFCIs. Some AFCIs are inherently more sensitive than others. Installing a different brand or model of AFCI may resolve the issue, as it may have a high tolerance for the transient currents or harmonics produced by the fan and speed controller. Thirdly, consider using a separate circuit. If feasible, dedicate an entire circuit solely to the ceiling fan and its speed controller. This can isolate the fan from other electrical loads, reducing the likelihood of interference or cumulative effects that trigger the AFCI. Fourthly, try bypassing the speed controller. If the fan operates satisfactorily without the speed controller, consider removing it from the circuit. This eliminates the potential for the speed controller's harmonics to interfere with the AFCI's operation. However, be aware that bypassing the speed controller will limit the fan's speed control functionality. Fifthly, install a surge protector. Incorporating a surge protector into the circuit can help suppress voltage spikes or transient surges that may inadvertently trigger the AFCI. It is important to note that manufacturers are actively researching and developing solutions to address this AFCI compatibility problem. For instance, Latron has released a new line of speed controllers specifically engineered to be compatible with AFCIs, minimizing the risk of nuisance tripping. In conclusion, the problem of ceiling fans and speed controllers causing AFCIs to trip unnecessarily is a recognized issue with multiple potential causes. While manufacturers are working on long-term solutions, the suggested fixes outlined above can provide immediate relief. Bypassing the speed controller remains a viable option when speed control is not a critical requirement. Remember to always prioritize safety and consult with a qualified electrician when working with electrical systems. The correct selection of electrical components is very important, and a few topics to consider include conductor selection, overcurrent protection, wiring methods, grounding, and working space around the electrical equipment. When selecting conductors, several factors need to be considered to ensure safety and compliance with electrical codes. These include ampacity, which is the current carrying capacity of the conductor, voltage drop, which is the reduction in voltage along the length of the conductor, insulation type, which must be suitable for the environment and application, and conductor material, which is typically copper or aluminum. Overcurrent protection is essential for preventing damage to conductors and equipment due to overloads or short circuits. Overcurrent protective devices such as circuit breakers and fuses are designed to interrupt the flow of current when it exceeds a safe level. The selection of overcurrent protection devices must be based on the ampacity of the conductors and the characteristics of the equipment being protected. Wiring methods refer to the techniques and materials used to install electrical conductors. Common wiring methods include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, flexible metal conduit, and non-metallic sheaths cable. The choice of wiring method depends on the application, the environment, and the requirements of the electrical code. Grounding is a critical safety measure that provides a low impedance path for fault current to return to the source. Grounding helps to prevent electrical shock and minimize the risk of fire. Grounding systems must be properly installed and maintained to ensure their effectiveness. Adequate working space around electrical equipment is essential for safety and accessibility. Electrical codes specify minimum working space requirements for different types of equipment. Clearances must be maintained to allow for safe operation, maintenance, and repair of electrical equipment. Additionally, it is important to know some of the potential electrical hazards in residential wiring and how to mitigate these risks include electrical shock, arc flash and arc blast, fires, and electrocution. Electrical shock occurs when a person comes into contact with an energized conductor. The severity of the shock depends on the voltage, the current, and the duration of the contact. Arc flash and arc blast are explosive events that can occur when there is a short circuit or other electrical fault. These events can cause severe burns, injuries, and even death. Electrical fires can be caused by overloaded circuits, loose connections, damaged insulation, and other electrical faults. Electrocution is death caused by electrical shock. It can occur when a person comes into contact with a high voltage conductor or when a person is exposed to a lower voltage for a prolonged period. To mitigate these risks, several safety precautions should be taken. These include always de-energizing circuits before working on them, using insulated tools and equipment, wearing personal protective equipment, following electrical codes and standards, and having a qualified electrician perform electrical work. Regarding the selection of appropriate lighting for different areas of a home have different lighting needs. The appropriate lighting for each area depends on the function of the area and the desired ambient. General lighting provides overall illumination for a room. It is typically provided by ceiling fixtures, recessed lighting, or track lighting. Task lighting provides focus illumination for specific tasks, such as reading, cooking, or working. It is typically provided by table lamps, floor lamps, or under cabinet lighting. Accent lighting is used to highlight specific objects or features in a room, such as artwork, plants, or architectural details. It is typically provided by spotlights, track lighting, or wall sconces. For living rooms, warm, inviting lighting is typically desired. This can be achieved with a combination of general lighting, task lighting, and accent lighting. For bedrooms, soft, relaxing lighting is typically desired. This can be achieved with a combination of general lighting and task lighting. For kitchens, bright, functional lighting is essential. This can be achieved with a combination of general lighting, task lighting, and under cabinet lighting. For bathrooms, bright, even lighting is typically desired. This can be achieved with a combination of general lighting and vanity lighting. For hallways, soft, ambient lighting is typically desired. This can be achieved with a combination of general lighting and wall sconces. Here are some tips for selecting appropriate lighting fixtures. Consider the function of the area, consider the desired ambience, choose fixtures that are energy efficient, select fixtures that are compatible with the decor of the room, and consult with a lighting designer or electrician for assistance. Also, know about the common types of electrical boxes used in residential wiring, their applications, and proper installation techniques. Firstly, there are outlet boxes. Outlet boxes are used to house electrical outlets, switches, and other wiring devices. They are typically made of metal or plastic and are available in a variety of shapes and sizes. Secondly, junction boxes are used to join or terminate electrical conductors. They are typically used in locations where it is necessary to extend a circuit or to make connections to multiple devices. Thirdly, ceiling boxes are used to support ceiling-mounted light fixtures and fans. They are typically made of metal and are designed to support the weight of the fixture or fan. Fourthly, weatherproof boxes are used in outdoor locations or in damp environments. They are designed to protect electrical connections from the elements. For proper installation techniques, choose the correct size and type of box for the application. Securely mount the box to a wall, ceiling, or other surface. Properly connect the electrical conductors to the wiring devices. Ensure that all connections are tight and secure. Properly ground the box and the wiring devices. Cover the box with a cover plate or fixture. Additional consideration should be made to local electrical codes and regulations to ensure compliance. When running cable through walls and ceilings, there are important steps to follow. Firstly, plan the cable route. Before you start running cable, it is important to plan the route that the cable will take. This will help you to avoid obstacles and ensure that the cable is installed safely and efficiently. Secondly, drill the holes. Once you have planned the cable route, you will need to drill holes through the walls and ceilings. The holes should be large enough to accommodate the cable, but not so large that they weaken the structure. Thirdly, run the cable. Once the holes have been drilled, you can start running the cable. Be sure to pull the cable through the holes carefully, avoiding any sharp bends or kinks. Fourthly, secure the cable. Once the cable has been run, you will need to secure it to the walls and ceilings. This can be done with cable staples, cable ties, or other fasteners. Fifthly, test the cable. Once the cable has been secured, you should test it to make sure that it is working properly. This can be done with a multimeter or other testing device. Here are some additional tips for running cable through walls and ceilings. Always wear safety glasses and gloves when working with electrical wiring. Be sure to turn off the power to the circuit before you start working on it. Use the correct type of cable for the application. Avoid running cable through areas where it could be damaged, such as near heating ducts or water pipes. Be sure to follow all local electrical codes and regulations. Here are some common mistakes to avoid. Do not run cable through holes that are too small. Do not pull the cable too tightly. Do not use damaged cable. Do not forget to secure the cable. Do not forget to test the cable. Next, let's talk about how to properly install and wire a three-way switch. A three-way switch allows you to control a light or other device from two different locations. To install a three-way switch, you will need the following materials: two three-way switches, electrical wire connectors, and a screwdriver. Firstly, turn off the power. Before you start working on any electrical wiring, it is important to turn off the power to the circuit at the breaker box. Secondly, identify the wires. There are 3 wires that you will need to identify at each switch location: the common wire, which is usually black, and the 2 traveler wires, which are usually red and white. Thirdly, connect the wires. At the first switch location, connect the common wire to the common terminal on the switch. Then connect the 2 traveler wires to the 2 traveler terminals on the switch. At the second switch location, connect the common wire to the common terminal on the switch. Then connect the 2 traveler wires to the 2 traveler terminals on the switch. Fourthly, test the switch. Once you have connected all of the wires, you can turn the power back on and test the switch. The light should turn on and off from both switch locations. Here are some additional tips for installing a 3-way switch. Be sure to use the correct size wire connectors for the wire gauge. Make sure that all of the connections are tight and secure. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician. Here are some common mistakes to avoid. Do not connect the common wire to the traveler terminals. Do not use the wrong size wire connectors. Do not leave any loose connections. And it is important to know how to troubleshoot common electrical problems in residential wiring. Firstly, power outages. Power outages can be caused by a variety of factors, such as storms, downed power lines, or equipment failures. If you experience a power outage, the first thing you should do is check to see if your neighbors are also without power. If they are, then the problem is likely with the power company. If your neighbors have power, then the problem is likely with your own electrical system. Check your breaker box to see if any of the breakers have tripped. If a breaker has tripped, reset it. If the breaker trips again, then there is likely a short circuit or overload in the circuit. Secondly, trip circuit breakers. Circuit breakers are designed to protect your electrical system from overloads and short circuits. If a circuit breaker trips, it means that there is too much current flowing through the circuit. This can be caused by a number of factors, such as plugging too many appliances into the same circuit, a short circuit in an appliance, or a loose wire in the circuit. To troubleshoot a trip circuit breaker, first unplug all of the appliances from the circuit. Then reset the breaker. If the breaker trips again, then there is likely a short circuit or overload in the circuit. You will need to call a qualified electrician to diagnose and repair the problem. Thirdly, flickering lights. Flickering lights can be caused by a number of factors, such as a loose bulb, a loose wire in the circuit, or a problem with the voltage supply. To troubleshoot flickering lights, first check to see if the bulb is loose. If it is, tighten it. If the bulb is not loose, then check the wiring in the circuit. Make sure that all of the connections are tight and secure. If the wiring is okay, then the problem may be with the voltage supply. You will need to call a qualified electrician to diagnose and repair the problem. Fourthly, dead outlets. Dead outlets can be caused by a number of factors, such as a tripped circuit breaker, a loose wire in the outlet, or a problem with the outlet itself. To troubleshoot a dead outlet, first check to see if the circuit breaker for the outlet has tripped. If it has, reset it. If the breaker does not trip, then check the wiring in the outlet. Make sure that all of the connections are tight and secure. If the wiring is okay, then the problem may be with the outlet itself. You will need to replace the outlet. Fifthly, electrical shocks. Electrical shocks can be caused by a number of factors, such as touching a live wire, using damaged electrical equipment, or standing in water while using electrical equipment. If you experience an electrical shock, it is important to seek medical attention immediately. To prevent electrical shocks, always use caution when working with electricity. Wear rubber gloves and shoes, and never touch a live wire. If you are not comfortable working with electricity, it is best to call a qualified electrician. Here are some additional tips for troubleshooting common electrical problems. Always turn off the power to the circuit before you start working on it. Use caution when working with electricity. If you are not comfortable working with electricity, it is best to call a qualified electrician. Also consider what are the safety precautions to take when working with electricity in a home environment. Firstly, always turn off the power. Before you start any electrical work, always turn off the power to the circuit at the breaker box. This will help to prevent electrical shock. Secondly, use insulated tools. When working with electricity, always use insulated tools. This will help to protect you from electrical shock. Thirdly, wear safety glasses. When working with electricity, always wear safety glasses. This will help to protect your eyes from sparks and debris. Fourthly, avoid working in wet conditions. Never work with electricity in wet conditions. Water is a good conductor of electricity, and it can increase your risk of electrical shock. Fifthly, be aware of your surroundings. When working with electricity, be aware of your surroundings. Make sure that there are no flammable materials nearby, and that you have a clear path to escape in case of an emergency. Sixthly, call a qualified electrician. If you are not comfortable working with electricity, it is best to call a qualified electrician. An electrician has the training and experience to safely and effectively handle electrical work. Here are some additional tips for staying safe when working with electricity. Never overload circuits. Overloading circuits can cause fires. Use the correct size wire for the circuit. Using the wrong size wire can cause the wire to overheat and start a fire. Replace damaged electrical cords and plugs. Damaged electrical cords and plugs can cause electrical shocks. Install ground fault circuit interrupters or GFCIs in wet areas. GFCIs can help to prevent electrical shocks. Have your electrical system inspected regularly by a qualified electrician. An electrician can identify potential hazards and make sure that your electrical system is up to code. Finally, let's look at the importance of using appropriate personal protective equipment, or PPE, when performing electrical work. Firstly, electrical safety gloves. Electrical safety gloves are designed to protect your hands from electrical shock. They are made of rubber or other insulating materials and are rated for different voltage levels. It is important to choose gloves that are rated for the voltage level that you will be working with. Secondly, safety glasses. Safety glasses are designed to protect your eyes from sparks, debris, and other hazards. They should be worn whenever you are working with electricity, even if you are just doing a simple task such as changing a light bulb. Thirdly, insulated footwear. Insulated footwear is designed to protect your feet from electrical shock. It is made of rubber or other insulating materials and should be worn whenever you are working with electricity. Fourthly, flame-resistant clothing. Flame-resistant clothing is designed to protect your body from burns in the event of an arc flash. It is made of special materials that are resistant to heat and flames. Flame-resistant clothing should be worn whenever you are working with energized electrical equipment. Here are some additional tips for using personal protective equipment when performing electrical work. Inspect your PPE before each use. Make sure that it is in good condition and that it is the correct size. Wear your PPE properly. Make sure that it is snug and comfortable and that it does not restrict your movement. Replace your PPE if it is damaged or worn. Follow the manufacturer's instructions for cleaning and storing your PPE. By following these safety precautions and using the appropriate personal protective equipment, you can help to protect yourself from electrical hazards.